Welcome to this Maths Made Easy video on basic trig identities. Now to start with, let's take a look at the first of our basic trig identities. And what I'm going to do here first is give the identity and then I will show you how to derive that result. So our first identity here is tan x can be expressed as sine x over cos x. Okay, so that's our first basic trig identity there. Now, if we can use some basic trigonometry here, we can easily show this result. Using the fact that we can express sine x as the opposite over the hypotenuse, so the opposite over the hypotenuse here. So opposite over hypotenuse. And we can also express cos x here as the adjacent over the hypotenuse. And we can use these ratios here, or trigonometric ratios, using this identity that sine x over cos x gives us tan x. Okay, so what I'm also going to do here, just to make this a little bit easier to write, I'm going to use the fact that the opposite can be expressed as O. So let's write these down here, just so we can see clearly. I'm going to express that as O. The hypotenuse will express as h. We'll express as h, and finally the adjacent as a. Okay. So when we use these throughout now, we're going to use O, h, and a here. Okay. So in that case, sine x over cos x, that's simply going to be opposite over hypotenuse, so that's going to be O over h. So we can write that as O over h divided by cos x, where cos x is adjacent over the hypotenuse. And again, using this notation here, we'll write that as A over h. That's A over h. And here now, taking a look at this fraction here, we've got O over h divided by A over h. Well, in this case, the hypotenuse is here, h and h will just simply cancel. Okay, what that's going to leave me with here is O over a, and we know O is the opposite, so we can write that now in full. So that's the opposite over the adjacent, and in that case, the opposite over the adjacent, we know that ratio is tan x there. Okay. And that gives us the derivation for our first basic trig identity. Rule 2 here on basic trig identities gives us our second basic identity. So first what we'll do here is give the result and then we'll show the derivation of that result. So our second identity is simply sine squared x plus cos squared x identical to 1. So here what we'll do is write our ratios for sine x and cos x. So sine x can be expressed here as the opposite over the hypotenuse. So that's up over the hypotenuse here. We'll just simplify these a little bit just to make this a bit easier to see. And then for cos x, we can express that here, cos x, as the adjacent over the hypotenuse. So we'll call that the adjacent over the hypotenuse. So if we're doing the sine squared x here, that's going to be the opposite over the hypotenuse squared. We can write that as opposite over the hypotenuse squared. And again, repeat this now with cos x. This is going to be the adjacent over the hypotenuse squared. And this is equal to 1. And this is what we're saying using Pythagoras Theorem. Well, here, just to make life a little bit easier, what we'll do is we'll say the opposite is equal to A. The hypotenuse is going to be equal to C, and the adjacent will be equal to B. So the adjacent is equal to B, and the hypotenuse is equal to C. If we think about our basic Pythagoras theorem here, A squared plus B squared equals C squared. And that's essentially what we're looking to show here. So in that case, if the opposite is A, this is going to give us A squared over hypotenuse, which is C squared. So this is A squared over C squared. Okay, we've got the adjacent over the hypotenuse here, And again, the adjacent is b, so if we square this expression here, it's going to be plus b squared over the hypotenuse, which is c, so it's going to be over c squared. And this is equal to 1. Okay. Now here we don't quite need these brackets, but just so everything's clear so far, we've got a squared over c squared plus b squared over c squared is equal to 1. Okay, so if we write that out here, without the brackets here, we obtain a squared over c squared plus b squared over c squared is equal to 1. Now if we express 1, so if 1 is equal to c squared over c squared, then we can replace that here. So therefore, a squared over c squared plus b squared over c squared will be equal then simply to c squared over c squared. And in this case then, if we multiply the numerators and the denominators here by c squared, what we're simply going to obtain then is a squared plus b squared equals c squared there. And that result there proves our identity. So that concludes this Maths Made Easy video on basic trig identities.